Alrighty guys, so today we're doing a short video on arithmetic functions and looking at them in terms of linear functions, or arithmetic sequences rather, and looking at them in terms of linear functions. Okay, so first thing that we're looking at on my notes is what is the definition of an arithmetic sequence? What makes a sequence an arithmetic sequence versus a normal sequence? Okay, so if it's an arithmetic sequence, that means there's a common difference between each successive term. Okay, and remembering a sequence is just a list of terms. That common difference is given the variable d. So whatever that difference is between each term is considered d. Now, we have a formula so that we can, because if you had a sequence of 5 terms, but they asked you for the 99th term, you would not want to have to figure that out all the way up to the 99th term by hand. So they give us a formula. Okay, and this formula includes what you're trying to find, okay, what the nth term would be, which is a of n, the first term in the sequence, the number of the terms, so if I was like the 99th term, 99 would go there, minus 1, multiplied by whatever that common difference is. So I can create an equation to match any sequence I want, or any arithmetic sequence, and then that way I can find any term I want. So let's look at an example of writing an equation to match an arithmetic sequence, and then trying to relate one to a word problem as well, a real world problem. Looking at my first example I'm going to do, looking at number 6, okay, the directions to this says, write an equation for the nth term of each arithmetic sequence and then graph the first 5 terms of the sequence. So, in number 6, the first thing I need to do, really the only thing I have to find before I start plugging in, is this common difference, okay? So I'm at negative 1, I go to negative 0.5 to 0 and to 0.5. So the common difference is a positive 0.5 every time. Alright, I'm going to come here in my extra space that I have at the bottom half of my paper, okay? And so for number 6, the d, the common difference is 0.5, okay? The first term is negative 1, and that's all we really need to plug it into this formula. So when I go back and look at my notes say a of n equals a1, which is negative 1, plus, a1, which is negative 1, plus parentheses, n, so this an and this n stay themselves, minus 1, multiplied by my difference, which is 0.5, okay? I do need to simplify this, so I keep my a of n, negative 1, the first simplify step is distribute this 0.5 in to get 0.5 in and negative 0.5, and then the last simplify step is to combine your two constants, okay? So, negative 1 minus 0.5 is negative 1.5. Well, your n term always needs to come first. So we're going to write our n term first, 0.5 in. These two combined give you negative 1.5, and this is your equation. Now, today I showed my students a separate way to do this, really zoning in on how this is related to a linear function. So a linear function, remember, is in that slope-intercept form, y equals mx plus b. M is that rate of change. B is when x is 0, what is y? So what is that starting amount? What is that initial term? Okay? Well, I can pick that information off of this from my list really easier than I can do this. Because that rate of change is how is it changing from one term to the other? That is the 0.5. So that m is the 0.5. And then your initial term, this b when x is 0, I might not want to say initial term because you may think it's the negative 1. That would be the first term. So your 0 term, your initial term, you would have, this is your first term, this is your second term, this is your third term, this is your fourth term. So to get my 0 term, I would just go back. So instead of adding 0.5, I would subtract 0.5 from the -1, which is what I did here anyways, and get that that b term would be the -1.5. And instead of using a y and x, just use the an. And I've got my 0.5, instead of using x, use the n, and then my -1.5. And I got the same exact thing. Uh-oh, put my decimal in the wrong place. So, when I go to graph this, okay, the way that our textbook taught this is to create a table of values for the first 5 points, 1, 2, 3, 4, 5. But the way I taught my students is just to use this idea of M and B. So my B is where I start, my M is 0.5 or 1/2, because that's going to be easier to graph because we like for our slope to be a fraction anyways. So we're going to start at -1.5 and we're going to go up 1 block and right 2 blocks until we have our 5 points. Now, our book does not include this y-intercept as being one of those points. So on number 6, we're going to put a starting point at -1.5. But we don't include that point as being one of our 5 points. Okay, so -1.5 is my first point. Now, I go up 1. Well, I guess what we should do, since we're talking about the first 5 points, is maybe let's just keep it on our paper. Let's just keep it 0.5 over 1 instead of changing it to that 0 or that 1/2, because that way this is going to give us the value at 1, the value at 2, the value at 3. So that will match what our textbooks need a little bit better. So if we're using 0.5 over 1, we're going to go up 0.5 and to the right 1. So we go up from -1.5 to -1 and over to 1, which matches their information because they told us their first point was -1. Then we go up 1/2 again to -0.5 and over 1. So their second term was -0.5, which matches what we need. Alright, up 0.5 again, over 1. So their third term was 0, which is what ours is. And then up 1.5 over 1. Fourth term is 0.5. And then remember, we don't count this one, so we only have 4 terms so far, so we need to go up 0.5 again and over 1. So our fifth term will be a +1. We don't connect them in this lesson, so that's all we have. Okay, so just kind of relating how an arithmetic sequence, their formula, really just matches my slope-intercept formula. Let me zoom out a little bit so you can see that. Okay, now, number 7. How can this match a word problem? Well, let's read the word problem. We have $525 in saving initially. After 1 month, she has $580 in the account. The next month, so after 2 months, she has $635. And after the third month, she has $690. Write in a function to represent this arithmetic sequence. Okay, so let's write down all these points. So in month 0, she has $525. In month 1, after 1 month, she had $580. After 2 months, she had $635. And after 3 months, she had $690. So the 2 things that we need to know to write this arithmetic sequence is how is it changing each time, and then what is that value at 0? What is that initial value? So really all we need to figure out is what does this change every time. So from 525 to 580 is 55, okay? 580 to 635 is 55 again, and then 55 again. So my change every time, that common difference is 55, all right? Or that M, if you're thinking about it in this term, is 55. So if I write my equation out, A of N equals 55N. And we could have plugged it into here using that first term, but we have. What was that initial amount that she had in her savings account at 0? So this is going to be plus 525. All right, so here's my function, and it said write a function and graph the function. So our graph, we're going to have M equals 55 over 1, B equals 525, okay? So on my graph, I think it would be best to count by 100s. So 100, 200, 300, 400.